Use number sense to solve one-step equations. An equation is a mathematical sentence that has an equals sign. An equation is like a balanced scale. To be in balance, a scale must have weights with the same total on each side. A true equation has equal values on each side of the equal sign. As we have looked at in the past, when we think of our equals sign, it's not some machine that spits out an answer on the other side. Essentially, what it's saying is, if things are equal, if the two sides of my equal sign are equal, they would mean the same thing. They would have the same value. So just like here, you would all say that 12 would equal 12. Are there different ways in which we can express 12 or write 12? Absolutely. Those are just two of the many ways in which we could show what 12 is, or the value of 12. Now, at the bottom of page 84, tell whether each equation is true or false. A, 7 times 9 equals 63. Is that a true or a false statement? Calvion. Very good. B, 4 plus 5, does it equal 45? That is false. And C, 70 minus 39, is it 41? False again. Should be what? $31 instead of 41, right? An equation with one or more variables is an open sentence. A solution of an equation is a value of the variable that makes the equation true. For example, in the open sentence, x minus 15 equals 12, what is it that we need to find in this particular equation? Yeah, what is x? Okay, right, we need to find out what x is. That's the missing value. We've gotten so used to over the years calling these our answers. What that is, potentially, is just a solution. I need to solve this equation. What is the solution? Okay, and who remembers how we go about doing that? There was a process which I introduced to you in the past. If you were here with us last year, you saw this, and it was maybe confusing at first. Raven. Well, close. If I need to find out what x is, I'd like to get my equation to say x equals, right? If I want to know what x is, I need to get x all by itself on one side of my equals sign. How am I going to get x all by itself? What is with x on this side of the equals sign? What's with it, Brandon? Yes, a negative 15 or minus 15. So now I need to do the opposite, and I need to do it to both sides. What is the opposite of subtracting 15? Trinity. Positive 15 or adding 15. And if to be equal, to be fair, I have to do it where? To just one side? Both sides. When I have my x minus 15 and I add 15 to it, the negative 15 combined with the positive 15 is what? Trinity. Not negative 30. Yes. Not positive 30. Raven. 0. So essentially, what is this? This is x plus 0 I have now, which is the same as saying just x. Oh, we're not finished. If I added 15 to this side, I must also add 15 to the other side. 12 plus 15 is... And how do I know for sure that 27 is the solution to the equation? Yeah, I plug it in. If I'm going to say that x equals 27, 27 minus 15, does it equal 12? Yes, it does. So it's all about doing the opposite of what's happening on the same side of your variable. Okay. So let's take a look at, let me give us a bunch here to look at. So W divided by 4 equals 20. W divided by 4 equals 20. What I need to find out is the value for W. Okay. Well, you fell into the trap. You said 5. But 5 does not make any sense in the particular equation until you go through the steps. What's happening on the same side as W? What's happening here? Josiah? Dividing by 4. What's the opposite of dividing by 4? Multiply by 4. When I multiply by 4, I will cancel out what's with my variable. And if I multiply by 4, 20 times 4 is 80. Now, how does this happen? When you had your assignment for today, how did I encourage you to write your division expressions? Did I encourage you to write them this way, or did we do it a different way? Did I encourage you to do it a different way? Yeah, W divided by 4. Now, how in the world does the opposite, multiply by 4, get W by itself on this side? We already said the opposite of dividing by 4 is to multiply by 4. What form is this in, Joe? You already said fraction form. So if I multiply or divide with fractions, everything has to be in fraction form. So let's look at that W divided by 4. I'm going to multiply it by 4 on that side. On this side, I'll multiply it by 4 like so. When I look and I say, okay, 4 and 4, anything in common? There's 1, there's 1. What's 1 times W? W. W over 1 is the same as saying W, right? And that would equal 80. Plug it in to our original. 20 divided by 4 is, 80 divided by 4 is 20. Okay, doing the opposite. Okay, now you may be able to use mental math for some of these. In fact, they will say solve using mental math. If you were to use mental math, you could just say, if I have 4.7 and I need to get to 5.9, how many more do I need to add to my 4.7? Brandon, 1.2. Now, if you can't figure that using mental math, can you switch the order here to know exactly what the opposite is? Or can you just go for it? Commutative property says we can add in any order. All right. Can I switch this around and have it mean the same thing? Sure. So then what's the opposite of adding 4.7? Subtracting it from both sides. When I subtract with decimals, I need to make sure I line everything up. And do I end up with the 1.2 that was suggested? I do. Okay. Bottom line is, if you do these the right way, it's still a good idea to check them. You have the opportunity to check each and every one of these that you do. You just have to take the time to plug your solution back into the original equation to see if it actually works. There are times in which they'll ask you to estimate. If they ask you to estimate, use what they give us and say, well, I probably don't want to use 6.14 or 6 and 1400ths. What might be easier to use for us mentally? 6, right? And not 23 and 800ths, maybe just 23. Now, mentally, I can say, all right, the opposite that has to get done to both sides is going to be what, Austin? Add what? How about add 6 to both sides, right? Because I'm subtracting 6. Let's add 6 to both sides. What's 23 plus 6? 29. Does 29 minus 6 give us 23? Makes sense, okay? What operation is currently happening right there? Currently, what's going on? Not opposite anything, what's happening right there. Trinity. Multiplication. I'll know that in order to get my solution, I need to be opposite of multiplying, which is what? Division. Knowing that right there should give me at least, or put me a little bit on alert to know that I cannot just divide any two numbers that I want. So just saying that I'm going to round the 8.2 to 8 and the 49.3 to 49, is that going to work out in my favor if I say, you know what, I'm just going to divide both sides by 8? Because 49 is not divisible by 8. Instead, let's go with this 8x, but then focus just on the first two digits of my 49 and say, what number closest to 49 would be divisible by 8? Leah. 48. Let's make it a 48. Then quite simply, x will equal 6. Okay? For estimation purposes, the exact is not needed, but close enough. Page 86. Take a look at numbers 1 through 6. Do those right now in class. Page 86. These are true-false statements. Numbers 1 through 9, true or false? Yes, you can use a T for true and an F for false. Just don't give me one of these. I don't know what that is. Okay. 10 through 21. 10 through 21 are very similar to the 7 through 14 that we just did. Okay? 22 through 30. Estimate the solution of each equation. Just look at 22. 6d equals 75. In other words, you would have to divide both sides by what if you wanted to isolate the variable d? 6. 75 divisible by 6? No. But you could estimate and come up with something close. That's where you'd say, what number closest to 75 would be divisible by 6? I will give a half a point extra credit for each of those from 22 through 30. So if you were to get all of them correct, you're looking at 4.5. I'd probably round you up to 5 extra credit points. Need I remind you the midterms come out on Wednesday. Oh, and there were a handful of you that did not handle 2-1 properly, I think, or 2-2. And were begging me for a redo, and I said, no, the one with the patterns that start with repeatedly, right? Well, even if you did, 5 extra credit points can do wonders for your grade. So just maybe a reminder that get some points back if you do those. 31 to 33, tell whether the given number is a solution to the equation. So for number 31, 3x plus 2x equals 10. If you plug in 2 for x, is it a solution? One way to find out, right? X is 2. 3 times 2. 2 times 2. Did it equal 10 when you plugged in 2 for x? So your answer would be yes. Okay. How about we'll make it even. I'll offer a half an extra credit point for 34 as well. So now there's 10 extra credit problems on the worksheet itself, half a point each. You can end up with 5 extra credit points. Okay? So 2-5, 1 through 9. Let's rewrite this. We'll get it right. 1 through 21. Extra credit, 22 through 30 and 34. And you still have to do 31 to 33. So make sure you get that down correctly. The extra credit problems are the ones next to the star. The required problems are listed there.